Okay, now I would like to tell you about the periodic classification of the element. There are 18 groups, which is column, and 7 periods, which is row in the periodic table. The periodic table also can divide it into 4 blocks, which is SPDF, which is the S is for the metal, P for the non-metal, and D for the transition element, and F for the inner transition element.
It's Joshua here, and I'm going to talk about the periodic classification of elements. Elements can be classified into metal, non-metal, and metalloid. Metals are good conductors of heat and electricity, whereas non-metals are not. Metals donate electrons to form cations, while non-metals receive electrons to form anions. Metalloids have both properties of metal and non-metal.
So now let's talk about the general trend of the periodic table. Based on this graphical summary of the general trend, we can conclude that if we compare helium atom and cesium atom, helium atom has higher ionization energy and electron affinity, while has smaller atomic radius and lower metallic character compared to cesium atom.
Now I will talk about the effective nuclear charge. Before we talk about the effective nuclear charge, we need to know what is nuclear charge. Nuclear charge is the total positive charge of all the protons in the nucleus. They attract and bind electrons to the nucleus. Z increases with the atomic number of the elements. Next, the effective nuclear charge is the net positive charge experienced by an electron in the many electron atoms, which affect atomic properties such as atomic radius, ionization energy, and electron affinity. Z is influenced by a magnitude of the nuclear charge and the electron-electron repulsions.
Now we will go to how to determine the Z in each atom. As we know, the negative charge of the electron will be attracted to the positive charge of the nucleus. But when the electron from the other orbit exists, it will be attracted, but at the same time, it will be repelled by the core electron or electron from the inner orbits. By this, we can conclude that the Z equal to number of protons subtract with shielding electron. For example, the number of proton of lithium is 3 and the number of shielding electron of lithium is 2. So, the net Z of lithium is positive 1.
Size of atom and ions. So here, we have the basic rules of size of atom, which is the size of atom basically decreases across the period, left to right, and increases down the group, top to bottom. Why? Because when going across the period, the electron valence in the atom will increase, thus increasing the Z or increasing the interaction between the valence electron and the nucleus. Therefore, more Z, smaller the size of atom. Meanwhile, going down the group, the shell of the atom is increased, so more shells means bigger size. Next, the size of ions. For cations, the size of cation decreases down the group and it tends to lose electron. This results in less repulsion between valence electron and shielding electron, thus making it smaller in size. As you can see, lithium atom has 1 valence electron, while lithium plus ion has 0 valence electron. For anions, the size of anions increases down the group and tends to gain electron. This results in more repulsion between valence electron and shielding electron, thus making it bigger in size. As we can see here, fluorine atom has 7 valence electron, while fluorine negative ion has 8 valence electron.
Thank you. Video prepared by Izan, Mirza, Danny, Kel, Ashraf, Amzar, Joshua.